This is 8.1 parametric constraints, and different than the numeric constraints we've been using up to this point, we are going to use some equations or formulas to drive the sizing of parts. So the first thing we're going to do is this cam lobe, and some of these instructions are from Autodesk Inventor. So I'm going to do the best I can to give you the visual example of this, and I've tried to modify numbers here so that they will work for you, and hopefully we can really, at the most basic, understand why we want to use parametric constraints to make parts. The main reason is so that they are scalable. So let's take this on, see if we can do it. We're going after a cam lobe, and the cam lobe is going to be drawn in Fusion. So I've got a new untitled project here inside a new project folder called Parametric Modeling Practice. I'm going to create a sketch, choose the surface, sketch a center diameter circle, and I'll click and drag out. And this first dimension here is going to end up being a diameter of 1, an actual number. And where we get that from in the instructions is that our dimension 1, the major diameter of the cam lobe, is going to be a value of 1 inch. Everything else for the cam lobe is going to actually be based off of a geometric relationship from the major diameter. So the minor diameter, that's the upper lobe. And if I have a finished picture here of the lobe, I think I deleted it because it was the D0 numbers were different. This is kind of what we're going after here is a cam lobe. The minor diameter would be this diameter up here, and that relationship is 1/2 of the major diameter. So we go back to Fusion, we could figure out that that should be a 0.5 inch value or a 1/2 inch value. I'm going to create another center diameter circle somewhere above here. And instead of putting in 0.5, I'm going to put D1 divided by 2. Enter. And that's going to give me an fx, or a function dimension, of 0.50. Great. So I've got my two circles there starting to come together. You can see over here what I was practicing on. And the last thing I have to figure out is the offset between those centers of the major and minor diameters. And that's 1/2 of the nominal diameter. So that's 1/2 of, actually it should be 1/2 of the major diameter as well. Let's just type that in the way it should be. So it's the same formula, D1 divided by 2. This isn't D times 1/2, just so we're clear. D1 divided by 2. So in Fusion, I'm going to hit the dimension key, click the center of this circle, and the center of this circle, drag out. And instead of putting in 0.5, I'm going to put, again, D1, that's that reference dimension here, divided by 2. Enter, and it drops this way down. Now, what I had trouble with figuring out is the way to get a tangent line to go from a line that's tangent to this circle to go to this tangent point on this circle. And what I figured out by trial and error is I hit the line key. If I choose up here at this 1 inch mark away and go to this point, this tangent point, click, hit the line key again, go from here to here, I get another tangent line. I'm going to do the same thing up here, here to the tangent point, and here to the tangent point. And the last thing I have to do then is trim this up. So under sketch, I can hit the trim key, which is T, and I'm going to trim away everything I don't need. I don't need this, 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 that, and that. And these are just reference extensions here. Right now, if I hit the E key to extrude, I do have a closed profile. I'm going to go at an angle here, and if I go back to my instructions here, what this is telling me about the thickness is I always want it to be 3/16 because we're going to scale this up or down in a second, and we don't want the overall thickness to change. We just want the size of the lobe to change. So my thickness is going to be 3/16 of an inch. Does not like that. How about 3/16? There we go. And I am done. I didn't put a hole in the middle as the instructions say. So if I wanted to do that, I could probably create a new sketch on this surface and a center diameter circle. I am modeling without a mouse, so I apologize for that. And this is going to be 3/16. Return and extrude. Oops. 3/16. There we go. Extrude. I'll cut that. Enter. Okay. And now if I want to change the size of this, if I go under Modify and choose Change Parameters, I've got to click into my Sketch 1. And this number right here, my 1-inch number, if I change this to a 5 and enter, I notice that my lobe scaled up 5x. Let's see if I can click OK and zoom out. And while I scaled up 5x, the hole stayed 3/16 of an inch, the thickness stayed 3/16, but I've got a 5 times bigger cam lobe. Cool. So the test for this is going to be that. I'm going to ask you to scale the part in front of me, and so that I can see that the parametric constraints are what's actually driving it. So under Modify, Change Parameters, I can see that here, all the driven constraints. Seen.